Welcome. Welcome, everyone. Good morning, good afternoon, good evening, according to where are you from. Welcome to today's webinar. I start indeed sharing my screen. Welcome to today's webinar, Decorative Outdoor Luminaire for Smart Cities, organized by the Zhaga Consortium and the DALI Alliance. I'm Valentina Ferrara. I'm Communication and Marketing Manager at the Zhaga Consortium. And I'm here today indeed to guide you through the technicalities of the webinar. Because indeed, as my job title says, maybe I'm not the most knowledgeable person to guide you through today's topic. That's why I'm here today with Mark Duffy, Chair of the General Assembly of the Zhaga Consortium, and Michael Davidson, Board Member of the DALI Alliance, and D4I Evangelist, of course. So no better speakers indeed to introduce you today's topic about Zhaga and DALI standard. As mentioned, I just wanted to, before giving the floor to the speakers, I just wanted to mention a few things regarding the flow of the webinar. This is the agenda. The first part will be of Mark, who indeed introduce us the Zhaga standards. Then we'll pass the floor to Michael, that we talk about the DALI standards. And at the end, there will be space for questions and answers. How you can ask your question is through the chat of the platform. So feel free indeed to write directly to me or to everyone publicly. I invite you to not wait till the end, so you get a higher chance, of course, that your question will be asked if you ask it first. And second of all, if for a personal reason, that otherwise I will stay here all the webinar asking myself if the chat is working or not. So I invite you to start immediately to write in the chat. For instance, you could say from where you're connecting, so I know if I should say good morning, good evening, or good afternoon to you throughout the webinar. Another technical point regarding the slides and the recording. As you heard in the beginning, a voice said that the webinar is recorded, and that's the case. We intend, if the platform works well, to send you the recording by the end of the week, together with the slides. Last slide from my side. This is, of course, a super interesting webinar. Here are the learning objectives. We expect indeed you to learn more about the DALI and the Zhaga standards. I wanted to remind as well that this webinar gives you 1 credit AIA credit. So if you need a certificate, you can write directly to me. You will receive an email indeed from me at the end of the week, so no need to note it down, but that's an information indeed I wanted to give to you. And this is it from my side. I leave the floor then to our first speaker, Mark. Mark, the floor is yours.
Okay.
Thanks a lot.
I'll get the sharing going.
Of course.
And then I will go to the slideshow. You should be seeing the first slide, which says Zhaga Consortium.
That's correct.
Good. So the Zhaga Consortium is an industry consortium that's nearing 700 member countries or companies with about 200 regular and associate members manufacturing Zhaga certified products and components. In 2025, we experienced a healthy 4% growth in memberships, and logos for the 25 regular member companies that participate in developing the Zhaga standards are shown here. The Zhaga interface specifications are collected into what we call Zhaga books. The interfaces are standardized for component interoperability and can include mechanical, electrical, photometric, thermal, and controller communication specifications. Zhaga's platform for smart cities is the popular Book 18, specifying smart interfaces between outdoor luminaires and sensing or communication modules. The most recent edition 4 was published for Zhaga members in November of 2025. Here's a history of the Zhaga Book 18, and it is full of innovation. It's also full of cooperation with the DALI Alliance and ANSI C136. This timeline shows the progress up through edition 3. Recently, Zhaga published edition 4 to expand the book to have relevance to decorative luminaires that are a major part of the smart city lighting infrastructure. The next slides will go through the history of this innovation. But first, let's take a look at the general idea of the Zhaga interface. Beginning with edition 2, this is an overview of the Zhaga Book 18 luminaire system. It begins with a luminaire housing containing internal electronics such as LED drivers to power and control the illumination functions of the luminaire. These functions can include dimming and color or spectral control. A luminaire extension module, LEX-R, is mounted into the luminaire housing, which is designed to mate with a luminaire extension module, LEX-M, and having a base plate, LEX-BP, according to the specifications in Zhaga Book 18. These luminaire extension modules are designed to provide additional sensor or communication functionality. In addition, a luminaire extension cap can be placed over unused receptacles for protection. A look at the electromechanical interface of the Zhaga receptacle and base plates reveals some details. The receptacle interface comprises 4 internal contacts and a central locator hole for easy alignment. A gasket assists in assuring both a firm twist lock action and ingress protection. The base plate interface contains a locking ring and mating surface to the gasket on the receptacle. The 4-pin contacts and the locating pin assure good electrical connections and easy insertion. An overview of the electrical and communication system of the Zhaga platform shows a luminaire with 2 LED drivers. These LED drivers are termed electronic control gear, and there may be up to 4 of them in a Zhaga D4I certified luminaire. The LED drivers power LED modules which provide the illumination function. In addition, the luminaire will contain a luminaire extension bus, a LEX-B, powered by a DALI bus power supply and connected to the LED drivers, and an auxiliary power supply unit, the PSU. Also connected to the bus are a pair of luminaire extension receptacles, LEX-Rs, which are mounted in the luminaire housing and available to receive luminaire extension modules, the LEX-Ms. Book 18 Edition 3 for smart cities includes luminaires having a 2-node hybrid architecture with both the NEMA 7-pin receptacle based on the ANSI C136.41 standard and 1 or more Zhaga receptacles. The vision starts with basic control functions such as power on, off, and dimming, and adds the DALI D4I driver to provide energy usage monitoring and reporting, as well as diagnostic and maintenance tools to assist in asset control. To this, the smart city designer can specify networking to connect with the IoT and have a citywide communication network. Finally, the vision includes the addition of sensors to provide the smart city with a large variety of functions. I like to imagine them as the digital equipment of our common sensing organs, eyes, ears, nose, etc. A close look at the NEMA ANSI C136.41 electromechanical interface reveals its main features. The receptacle has 7 contacts. The inner 3 contacts carry the mains connections of neutral line and load. The outer 4 contacts stand ready for sensors and auxiliary power functions. The mating base plate has 3 inner pins for mains connection and the 4 outer contacts to match up with the receptacle. Book 18 has made a specific selection of contact configuration type 1 from ANSI C136.41 to ensure interoperability of Zhaga D4i certified components. The mains power is connected to pins 1, 2, and 3 in the central circle of the twist lock interface. Contacts 4 and 5 are designated for DALI communication or sensor data function. Contact 6 is a plus 24 volt DC to power the sensor and or communication device. And contact 7 is specifically specified as disconnected. A key aspect of the Zhaga Book 18 platform is compliance to DALI requirements. Control devices mounted on a Zhaga receptacle are required to be type A or type B as specified in DALI Part 351 luminaire and luminaire mounted control devices. A DALI type A control device has an integrated multi-sensor application controller and supports 2-watt average power consumption from the auxiliary power supply. DALI Type B control devices have either an integrated multi-master application control with an arbitration algorithm or for one or more input devices or both, and support 1-watt average power consumption from the auxiliary power supply. In case of Type A LEX-M and Type B LEX-M are both attached to the luminaire, the DALI application controller for the Type B LEX-M is disabled and the DALI application controller of the Type A LEX-M controls the system. D4i certification ensures a proper arbitration control protocol and availability of energy metering and reporting, luminaire data diagnostics for performance monitoring and fault detection. If occupancy or daylight sensing is included in the functionality of the luminaire extension module, then compliance with the DALI Part 103 general requirements control devices is required. In a similar fashion, for the 2-node architecture, control devices mounted on a NEMA ANSI C136.41 receptacle are required to be Type A as specified in DALI Part 351. The desire for smart cities to deploy decorative and heritage luminaires should not prevent them from joining the smart city vision. Zhaga Book 18 Edition 4 features a solution for a pole-mounted bracket assembly containing 1 or 2 Zhaga 4-pin interfaces. This enables these decorative heritage luminaires to become part of the smart city lighting system. The basic architecture of a Zhaga Book 18 Edition 4 decorative luminaire system comprises the luminaire with a pole-mounted bracket assembly. The luminaire portion of the system may have either 0 or 1 connected module, whereas the bracket assembly may hold 1 or 2 modules, provided that no more than 2 modules are deployed within the system. An example of a bracket assembly is shown in the pictures. New certifiable components in the Zhaga Book 18 Edition 4 specification include Zhaga D4i specification for the luminaire, having the Zhaga cable, and Zhaga certification for the bracket assembly. On the left, the 6-core cable and plug serving the power and signal needs of a luminaire is shown. On the right, a 3-core cable and plug are shown, which carries the plus 24 volt DC and DALI signals to the bracket assembly. A breakout cable assembly is needed for internal connections in the Zhaga certified decorative luminaires. The breakout cable assembly combines a 6-core cable and 2 3-core cables to supply both mains power and signals in the decorative luminaire system. 2 polarization keys have been designed and specified to ensure proper configurations of Lexar nodes for the Book 18 Edition 4 luminaire and bracket systems. Key 0 indicates that both Lexar nodes are on the bracket. Key 1 indicates that one Lexar on the luminaire and one on the bracket. This slide shows possible correct configurations for Zhaga certified decorative luminaires, including a configuration having only one Lexar node. Electrical disturbances are unavoidable in the outdoor lighting systems. Hence, surge protection for the system electronics is necessary. The Zhaga Consortium and DALI Alliance have cooperated to develop specifications that protect Zhaga D4i decorative luminaires in Book 18 Edition 4. DALI Parts 151 and 152 are being amended to address the needs of decorative luminaires and control devices. Zhaga Book 18 Edition 4 includes mandatory surge protection referencing these DALI Parts 151 and 152. Bracket-ready luminaires come equipped with receptacles, Lexar, cables, and surge protection devices. Specifying bracket-ready decorative luminaires prepares them for participation in smart city lighting systems. The next slides help one to confidently specify Zhaga D4i products from the multi-vendor database. Zhaga D4i is a joint certification program between the Zhaga Consortium and the DALI Alliance for dual certification of interoperable luminaires, sensing or control devices, and communication modules. Certification is based on Zhaga Book 18 plus DALI D4i specifications. The certified products carry the dual logo as shown in this slide. The logos indicate multi-vendor product interoperability and simplifies the specification and tender process. So look for the logo and select future-proof luminaires at the start of your projects. Supporting the dual Zhaga D4i logo are products that, by their nature, can only be certified by either DALI D4i or the Zhaga specifications. The LED drivers are eligible for D4i certification from the DALI Alliance and will carry this D4i logo. Conversely, receptacles, bases, and caps from Book 18 are eligible for certification from Zhaga and will carry this Z logo. To sum up the last two slides, Zhaga and DALI certified products make it easy to specify with confidence that it works, it's repairable, it's adaptable, and it's available. Features of Zhaga D4i certified products make several advantages clear. The ability to easily add new sensors or upgrade communication modules to existing luminaires in the lighting system makes Zhaga D4i products resilient and supports a circular economy where the luminaire is repurposed rather than discarded. Specifying Zhaga D4i certified luminaires opens the ecosystem of multiple vendors supplying interoperable products, reducing the vendor lock risks associated with proprietary systems. The intraluminaire D4I interface enables bidirectional communication between sensors and/or communication modules and LED drivers. D4I certified LED drivers can report operational and diagnostic data to an external network and provide inventory-related information about the luminaires. Finally, a suitable wireless communication module, the luminaire can become part of the IoT. I want to wish everybody a happy Earth Day and move into the idea of right to repair, upgrade, and reuse. Formally, the term right to repair comes from the National Conference of State Legislators, and the right to repair ensures that system owners can fix their products without being forced to use manufacturer authorized services. Various states are actively developing right to repair legislation. Let's look at how Zhaga can help. The aims of a circular economy are to limit consumption of resources and raw materials, as well as avoiding landfill waste. Armin Conrad, an active regular member in the Zhaga Consortium, expressed the concept of circularity lighting and serviceability very succinctly. Armin points out that the key to serviceability is modular design through standardized interfaces. Serviceability requires luminaires and light management systems that can be repaired when broken, upgraded as technology advances, and replaced when necessary. That is where Zhaga comes in and develops specifications for standardized interfaces enabling LED luminaires to promote a circular economy. And now we go over to the DALI presentation that Michael Davidson will carry us through.
Thank you, Mark. Michael, the floor is yours.
Thank you. Let me start sharing here. Excellent presentation, Mark. I appreciate that very much. It was awesome. And we should be able to see my screen here. Let's go back to the top here. And let me introduce myself. I'm Michael Davidson. I'm a system architect for Synapse Wireless. What I'm going to be talking about today is plug and play. It's been a long dream in a lighting space. There's been too many times where a luminaire will die and it's really hard to replace it. You can't, the drivers aren't
I
compatible, the light
interrupt you
engines
quickly,
aren't
Michael,
compatible.
just to make sure that we see it in the slide deck and not in presentation mode. It's the
Oh,
same in
okay.
case, but so at least you know. Sorry.
Thank you so much. No,
You're
that is
welcome.
so awesome.
That is perfect. Thank
Oh,
you.
thank you. So, plug and play has been something that's been a dream forever. And finally, we have plug and play with D4I. I've been evangelist for D4I over 8 years. And the reason is it provides reduced complexity and fewer components for higher reliability. The basic components of plug and play are standardized LED drivers and standardized connectors. If you have those components, it's just like blocking and tackling in football. It's very basic stuff. So now you can swap out the controllers. Not that we want you to swap out controllers if they're ours, but it gives you that capability because it's a certified controller. You can plug it right in. It works right with the drivers. If they're D4I drivers, you can swap out certified, bona fide D4I LED drivers. Then bingo, bango, bongo, you've got, a compatibility. So who's seen DALI 2 D4I in operation? And this is a trick question. Okay, I see a few hands raised. Okay, yeah, a couple more. Well, let me kind of everybody in North America has been to a Target store. In Target stores, the parking lots, the canopies, parking decks, even the ambient light sensor that turns on the signage for the big Target signs are all controlled by D4I. So besides that, there's lots of parking lots, stadiums, auto dealerships, roadway are all controlled by D4I. You just don't know it. You don't see it. It's inside the luminaires. But there's over, 3 to 4 million D4I luminaires in North America. Go to Europe, there's a ton more, millions and millions. So this presentation's a test, and let's start with the answer first. I'm going to kind of go through example of, I had a customer call and say, hey, we got these new controllers and some new software, and we got an issue. We got a light out. So what do I do? How do I help that customer? Do I roll a truck? No, I don't roll a truck. Guess what? We have D4I luminaires out there. So we'll pull up a dashboard, go to the light on the dashboard, verify the power readings, correlate to the dim level for the wattage for that luminaire. So that if things looks good, what do I do next? Roll a truck? No, not yet. But look at the schedule and scenes to verify the light's behaving as it should be. Should it be on? Should be off? Time of day, schedules, motion. So what do I do next? Do I roll a truck? No, not yet. I'll look at the light alarms, see if there's an issue with the light folding back current every day. And once I see that issue, then what do I do next? Roll a truck? Maybe. If the light's still functional, but it's folding back current, it could be an issue with a driver, could be an issue with the light array, but it's something you can schedule for a truck roller maintenance investigation later if the light's still functional. And you can tell if it's functional by turning it on and off and looking at the power levels. So you can do this definitely with D4I, and also you have information like current foldback or temperature foldback or over voltage or under voltage. So some of these things we'll look at in greater detail. So just a quick introduction to D4I. What is D4I? It's smart lighting. Smart lighting fixtures enhance the energy savings. It makes lighting a key driver in the Internet of Things. So where is better lighting needed? Everywhere, classrooms, stadiums, parking lots, warehouses, factories. Better lighting is going to provide better satisfaction, less failures, plug and play, and compatibility that you wouldn't get otherwise. Just a quick look at the architecture for a combo sensor for D4I. As you notice, the top diagram is a traditional AC input. Both of them have, but it's 0 to 10. And it's not a combo sensor. And I'm going to introduce combo sensor to you today. Combo sensor is a combination controller, motion sensor, and ambient light sensor. So the top block diagram has a lot of components. There's a lot of stuff. There's a lot of things can fail. The diagram on the bottom, fewer components. It has a data bus, and this can provide you asset data and diagnostic data and power monitoring data that you wouldn't get from the block diagram in the top. So what is D4I? It's how plug and play is accomplished. Interoperability, designed features that are required. You must have them. They're certified feature sets, and they're smart. They provide you information of what's going on with that light. The key is it's certified. If it's certified, that means whoever you put in that light, it's going to work just as you intend it to work. So interluminaire, is where we focus D4I, but D4I can be in, DALI systems, but that's not what we're really talking about today. These standard features are things that we like to see with our, if we got a combo sensor, it's going to need some power to generate, turn it on, operate. Of course, if it's D4I certified, you can use the D4I logo. So be looking for that on luminaires, look for it on controllers, look for it on LED drivers. It'll be printed right on the components. So people sometimes have asked, what is a bus when you're talking about LED driver? It's where commands and data are transported back and forth from the driver to the controller. So with a 0 to 10 driver, you just give it commands that dim. That's all you really can give it. Whereas if you have a D4I LED driver, you can give it commands to dim, control scenes, get power monitoring, figure out asset data, figure out diagnostics as well. So benefit summary, to sum it up, D4I is, the bomb. It's got a lot more check marks. 0 to 10's got one little check mark. To meet DLC and ASHRAE requirements, these are the key things to have. And the Trojan horse to ensure, things are functioning well as energy savings is the power monitoring by D4I. So you can meet energy standards, you can get rebates, as well as you can tell if that light's working. Is it functional? Is it providing if it's a 100-watt fixture, 100%, is it showing 100 watts, or 50%, is it showing 50 watts? So it's the Trojan horse. It really is something I use all the time, trying to figure out, is this light working and what's going on with it? I get frustrated if it's a 0 to 10, fixture. I can't tell anything. I can't see what's going on. All I know is I'm giving it commands, and hopefully I can look at that light. But lots of times when you're diagnosing and doing remote diagnostics, you can't see that light. You can't tell what level it is. Here's some specifications that make this all happen. And that's how you get plug and play, is there's standards written and you have to meet those standards. So here's just a few of those standards that make up D4I and certification. And there's a big old piece of test equipment. OEMs will put, or test houses will put the drivers, the controllers, the sensors on there, and they'll just run through a test suite. If you pass that test suite, that means you've met all these specs. Power supply specifications. Here's something that's been confusing lots of times if somebody's a new user to D4I. There's 2 power supplies, and it's kind of confusing. There's one power supply for the DALI bus, so it's got to have power on it, so that bus is enabled, and it can work and pass data back and forth, receive commands, and provide data back. But also there's a power supply that drives the controllers. So these are 2 requirements, for interluminaires that are real common and real important to know, that there's 2 different power supplies. D4I specifications, these are some things that really are kind of the icing on the cake. It's almost like just a beautiful ice cream cone in the summertime. You have luminaire data. So you got information on the luminaire, which is key if you're going to replace that light. What is the light distribution? What's the ID code? What's the date code? So all this is key information for the assets. And energy reporting, which is power monitoring. This is really helpful in understanding, how much power you're using. It allows you to understand your savings. If you can't measure it, how can you save? So lots of times, this is something that will really drive people who are using motion sensors. They can report the energy savings right off the bat. We've seen customers with large parking lots save up to $1 million a year by using the power monitoring and measuring, the motion sensors, the lights coming on and off, at night when people are around or not around. So also diagnostics and maintenance. This really key is for failure conditions, runtime data. Allows you to see if there's issues with the incoming power, if there's issues with the LED arrays. So the diagnostics are really key for maintenance and understand what's going on. Just for control devices, there's a part 351. It's just a set of specifications that talks about and defines, what does that control device have to do? And it's mandatory for certification. You have to meet the timings, you have to be able to do certain functions, and it's key for plug and play that is D4I certified. Here's just a quick look at the luminaire and the guts inside it. You got the D4I driver, aux power supply provided by the driver, LEDs, you got power and data provided, and you can talk to sensors through the bus. And now you got motion sensors or ambient light sensors as well. For outdoors, there's two methodologies to connect a D4I controller to a luminaire and to D4I driver. There's the Zhaga socket, and also there's the Book 18 Zhaga socket. So both these are another component for plug and play. Standard sockets created by standard committees, and it's key with the drivers and the sockets to have plug and play. Just a little bit of information on recap of the different DALI specs, D4I specifications, and also the Book 18 specifications. So the mechanical interface is well defined. It'll be the same for everything. So ANSI 137.4 is a standard for the ANSI, and it maps right into D4I. So these two organizations work closely together to make sure that they map right into each other. And so it's not like they're just independent, they're working together continuously. So everything that's in the ANSI 137.4 is directly maps and aligns with DALI D4I. So DALI Alliance, spends time with the ANSI committee and vice versa. Both, D4I and ANSI 137.4 standards are updated. A collaboration of, top companies in the lighting industry. So another thing about working with different alliances is, DLC is very involved in the specifications as well, and requirements for rebates. So all three organizations are tightly aligned and communicate and participate in committee meetings. So it helps, standardize, data formats, encourage, how the data is used. And also this accelerates, adoption and, of connected lighting and networked lighting controls. And the big piece of it is when you get certified and you have your lighting components, DLC certified, this is going to drive quality products. It's going to make sure that when you buy something, it's going to provide all the features you need for the energy savings. Well, try and get my slides to advance here. There you go. Now, you're just kind of wondering is how do I find, D4I certified products? First of all, just go to the DALI Alliance and select products. Here's just some examples of some of the D4I drivers on the left, the LED drivers. Just, you type in control gear, which is kind of confusing, but it's LED drivers, or control application controllers, which is on the right. And this is examples right off the website. And today, globally, there's over 7,500 certified D4I LED drivers. For North America, there's over 185. We're talking all wattages from 20 watts all the way up to 1,200 watts. So all voltages too. 480 volts, 347, universal voltage is 120 to 277. So it is really well represented today. 5 years ago, there's only a handful. Today, there's a lot. Control devices globally, over 150. In North America, over 35. So, you say, okay, well, there's a lot of certified LED drivers, but wait a minute. Something to really think about is what's happened is all these D4I drivers are programmable. They're programmable. So what does that mean? Well, there's a wide range of current output. So that means you'll have a lot of SKUs coming off of one driver. You can have 10 to 20 SKUs coming off of one driver. So they're programmable. You could put, depending on the current range, it can be 700, milliamps to, 1200 milliamps and anything in between, so that almost any LED array, we can find something to fit for it and then create multiple SKUs off that driver. Here's just a quick, look at, input device, application controller, LED driver, how it comes together. With D4I, it's just a standard for, what I call it, DALI for IoT, which doesn't really stand for that, but I think that's where you get the data. You want the data so you can do diagnostics. The asset data allows you to replace, know what features that light has remotely. It's stored inside it, so you can pull that data, have it in your dashboard, and know exactly what fixture you have on the Cobra heads or on the side of the building for the wall packs, or the troffers inside the building. So which OEMs application controllers use D4I? Gosh, there's over 75 luminaire OEMs that use D4I drivers when there's a customer demand. A lot of them have SKUs. We work with a lot of these OEMs. They're tier ones, tier twos, tier threes. So just ask your provider for D4I. Specify it when you're specifying your lights. And but it's out there. It's available. Lots of times you just don't see it because you see the lights, and if it has D4I on it, you've got a smart light and you have a lot of functionality. So here's just some examples indoor. There's quite a few OEMs doing this. Outdoor, you got dashboards, you got reports, your occupancy, energy, there's a lot of things available with the smart data. Warehouse, outdoor, sports applications. Some of the key, D4I diagnostic data that we talked about a little bit earlier is temperature, thermals, output voltage, output current, input power, driver part number, serial number, fixture rated power, over voltage, under voltage. We use these all the time to diagnose problems people are seeing. So I just skipped over a slide accidentally. I just want to show you this one slide here. Is the neat thing is when you're doing, D4I drivers, on their dashboard, you can go look at the number of DALI drivers in a luminaire. So this is a sports, fixture. It could be a roadway fixture, but it shows you've got the short address, so you know which one driver you're talking to, the GTIN number, so it's the identification number globally. shows the manufacturer, of the driver, shows the part number. Oops, accidentally went backwards. So anyway, here's 4 drivers in this fixture for sports, but also you can have, in the parking lots, you can have, 2 drivers in the Cobra head. So standards are essential for anything. For success in adoption, you got to have standards. So you've got intelligent luminaires that have standard data, standard connectivity. And believe it or not, with the sockets, you're future-proof in your future. So if ET could phone home, how come your lights can't phone home and give status of what they're doing, what's going on with them, and have you be able to investigate and put a little intelligence into what you're doing, to kick out reports, to show you, what's happening. So here's just an example of some alarms at a facility. It's reporting control gear under voltage. Here's another one that's showing control gear output power limitation due to an issue. So these alarms are readily available in D4I, so it makes it easy to diagnose what's going on with a particular light. Here's a use case. This is San Francisco Giant Stadium, Oracle Park. And here's just an output of different diagnostic data. And you can notice at the very top, there's a light that's on and all the rest of them are off. So they gave us a call and said, how do we figure out what's going on with this light? We went, looked at the diagnostic data and, looked at it and said, okay, there's an issue here with the input voltage. And we said, we think it's a floating neutral. So they went to that pole and that found out there's an issue with the wiring. So otherwise, they would probably gotten a lift, taken the light apart, tried to figure out what's going on, but it's actually the wiring inside the pole that created that issue with that light. So D4I, it's fun. Why not specify D4I? Not only is it fun, it's going to provide you some, I guess, insurance of saving energy. It's also going to provide you sleep when you know that your lights are working and why they're not working if they are not working. And that concludes the D4I part of the presentation.
Thanks a lot, Michael. I think we have time indeed for a couple of questions, and I want to invite everyone in case you have other questions to write it in the chat anyway. The speakers promised me that they will get back to you after the webinar. In case I go in order, I see 2 that you can see and 1 direct message. So the first is from Rob. Can D4I drivers supply DALI bus power and auxiliary power, or do you need a second power supply for bus power? I guess this is for Michael. In case I read it too fast, you can read it in the chat as well.
No, it's, yes, the D4I drivers provide the DALI power supply and the auxiliary power supply. They provide both. And the auxiliary power supply is always on. You can turn off the DALI power supply, but for our applications, we like it turned on. So everything just works out of the box.
Perfect. Then the direct message that I received was, has the issue of light pollution been considered? And adding a comment, as more commonality of components and system will help manufacturers and users adopt products which will help tackle this issue. Anything to say about the topic?
Yes, I think the more control you have of the light, the better you can do with light pollution. And with network lighting controls, you can do a lot of things. You can do high-end trim to limit the amount of light output on that particular light. Depends on, it might be on an entrance or it might be on the back of a building in a park, or it can be a parking lot, next to, a subdivision. So controls allows you to dim those lights, put them on schedules, have certain times the lights go off or dim to a level that's not as much glare. But also the OEM for the manufacturer of the luminaire can do stuff like put shields on the lights where you might not get backlight behind it or side light wherever you need to get the light to go. They can put shields on there to do that. They can also direct the LEDs. They have like lenses that'll throw the light in a certain direction. But without controls, you can't, like for instance, there's areas like near ballparks and stuff where they want those lights to go off, when kids are going to bed or dim them. So with controls, you have a lot of, flexibility.
I don't know if Mark, you want to add anything.
No, Michael covered the question.
Yeah, perfect. So I have another question from John. With regard to D4I, how is designed for circularity? The question that goes along with some comments. One device controller with many operation, all good, one guy doing everything. But if one part of, say, D4I driver, device phase, wall device phase, and wall device goes to waste, could the D4I drivers not be constructed to be modular, but integrated like a desktop PC, so as to promote repairability and circularity, and hints to the EU lighting regulation in this case? It's a suggestion.
That was a lot of several questions. Let's see. I need to look at the chat here.
But in the meantime, I can give you a good news because someone commented Zhaga D4I outdoor luminaires become a standard specification for most European tenders now. So that's good to hear from the chat.
Yeah, that is very positive. We just need to get North America to make it part of the tenders, which we're seeing more and more, with all the standards of ASHRAE 9.1 and ANSI and DLC, we're seeing more and more people requesting network lighting controls and D4I. There's actually a DLC seminar tomorrow on smart drivers, which will be, include, the D4I. Jonathan's question, part 306, fitting Zhaga D4 ecosystem. Mark, I'm gonna leave that one to you because as you know that, you know, in North America, most of I'd say probably 90% of the providers of D4I luminaires and controls, we're not Zhaga D4I certified. We have Zhaga sockets and we got D4I sockets, and we don't, play like that. Won't go into that now, but I'll let Mark address that if you'd like.
Well, I'm not exactly certain how to address that. Part 306 of DALI is does what now, Michael? What is part 306?
306, I think, has to do with sensors.
Okay.
It's a trick question from.
It's okay. We know it's it's a friendly question.
It is.
So I don't know if ANSI has adopted Part 306 in any way into their specifications, but this proposal could come as a proposal for ANSI to take a look at in C137 for lighting systems. It makes some sense there. And all I can say is that the cooperation of ANSI, DALI, and Zhaga in terms of each adopting or referencing the others' work, good work, continues to go on. And I would basically say that in North America, it is very, very common to require in your tenders ANSI or ANSI compliance. And so one of the things that has been helping is to take things from DALI or Zhaga and bring them into ANSI so that you can say this is ANSI compliant. I don't know, Jonathan, if I've addressed your question directly, because I'm not that familiar with all the numbering
Look,
of the parts.
hey,
But
Mark, let me move on to this other question about circularity. I think this is a great question.
oh, sure.
So I was just on a call the other day with one of the major OEMs, and their new fixtures come with a tray, 2 screws, and you can remove the LED driver. So they've designed it where you can easily order that tray and take the old one out and put the new one in. The same thing with their LED arrays, 2 screws, and you can move the LED array board and put a new one in. So there's work in North America, and I'm sure that it's been in Europe for a while now, but that's where it's going today for circularity. And DLC has been pushing really hard for circularity. And when you do retrofits, you don't want the light fixtures to go in the landfill. You want to be able to replace the key components. And with the connectors, the Zhaga connectors, you can put a new controller on. I really encourage everybody to go to the DALI Summit. There's going to be, one in Dallas here later in the year, and there'll be, demonstrations. The last 2 DALI Summits is they put a fixture and replaced the controller and showed operation of that fixture, and vice versa. I did one where I replaced the driver and turned the light back on, and boom, it's still working and functioning just like before. So there is circularity. That's the plan. It's just getting adoption, and it's moving pretty fast right now. A lot of the end customers are demanding, repairability, because right now it's kind of difficult to repair things. You can take them out, but there's a lot of screws. You got to move stuff around, and they just want things to snap in, and that's where it's going. Let's see.
I have to act as a technical moderator of the session because it's nearly 2 minutes to go. So I guess it's time to wrap up. But as mentioned, the questions are there. I will provide them to the speaker and we'll get back to you. I want to thank you, of course, everyone that joined the webinar. Keep the question coming, and Michael and Mark for the excellent presentation. As mentioned in the beginning, you will receive slides and recording at the end. I don't know if you have a few last words, Mark and Michael, before I close.
Plug and play. That's the key.
Yeah. So
Zhaga sockets.
So thank you, everybody. If you want to visit the databases, those are very useful for identifying available products. And the other thing is consider joining Zhaga if you are a manufacturer, or DALI if you manufacture electronics. I think you will be joining a good group of people who are trying to make standards for interoperable components. Thank you.
Visit the Zhaga booth and the DALI booths at next trade shows that you attend.
Mm-hmm.
Great. Thanks a lot, everyone. And see you next time. Bye.
Thank you.
Thank you.